something Disney and animated. So, all right, let's talk topic 7.1, adding and subtracting rational expressions. So we are going to do the explore here because it's where we talk about excluded values, okay? So what does, just in general, the word excluded mean? What do you think the word excluded means? Can you tell me in the chat, what does excluded mean? Just basically, what does it mean? Okay, I've got not involved, not part of, isolated, not part. It's kind of how we all are in the pandemic, right? We are all excluded right now, right? Left out, not part of, not included. Okay, perfect. You understand what excluded means. So basically, we're going to have a value that we leave out, okay, that gets excluded from the party. The one thing that we are not allowed to do is we are not allowed to divide by 0, okay? So I'm going to write that out in the left-hand column, that we cannot divide by 0, right? If we divide by 0, our paper explodes, right? And we don't want any explosions on top of whatever else has gone on this last year. So do not divide by 0, okay? You write undefined, right? So when we are talking about an excluded value, it's something that's going to make our denominator equal to 0. Okay, so we don't want our denominator to be equal to 0. So basically, they're going to step us through this. This is way more time, way more of a page than I would spend on this normally, but it explains it fairly well. So the denominator of the expression is x minus 1. All right, division by 0 is not defined. The excluded values for this expression are all the values that make the denominator equal to 0. So I take that expression x minus 1, set it equal to 0. And what would I get when I solve it? Can you tell me in the chat? What would I get when I solve it? Yes, we would get x equal to 1. So this here is the excluded value. Okay. So I get that as an answer. I cannot have it as an answer. And I think in this example, we're going to see the excluded value pop up here. So we're going to begin by factoring the numerator. And I know it's written really kind of backwards. Your book likes to do this kind of stuff to us. So what if I've got 1 minus x squared? What kind of factoring is that? Anybody remember? It's 2 terms. You got to ask yourself, are they squares? Are they cubes? What kind of factoring do I have there? What do you think? Ask yourself if you're adding, if you're subtracting. What do we think? Hoping there's a delay. Okay, Roxanne, a suggestion on how to factor it. Does anybody know the name of that kind of factoring? Because we're going to see it pop up. There we go. Good job, Angelica. Difference of squares. Okay. So when we do difference of squares, we are going to take the square root of the first term, which Roxana correctly identified as 1. We're going to take the square root of the back term, which I like. Roxana made an attempt, but the square root of x squared is just x, and we're going to make 1 a plus and 1 a minus. Now, there were lots of ways to do this next step, okay? I am going to put that in there, okay? All right. But what they did here was they were trying to force something to cancel on the top and the bottom. And that's why today is so fun, is we're going to see things, and especially tomorrow. Tomorrow is even, or whatever we do, whenever I see you again, Friday. Friday is even better, okay? So, because we get to cross stuff out, and cross stuff out, it's fun, man, right? So what I'm going to do is I'm actually going to factor a negative out of this. So when I do that, if I pull out a -1, I swap my signs. And then what happened here is we wrote it in the opposite order. They just did the commutative property and switched the order. So now I can cross these guys out. And technically, I'm dividing by a -1, so I could also float that negative in front. So I've got -1 plus x, which is equal to -1 plus x if we distributed. Okay. So the simplified expression is -1 plus x when x is not equal to our excluded value 1. I'm not going to worry about the domain and the range. We're going to cross that out. Okay. All right. So as long as I didn't get 1 as the final answer, we'd be good. So we're going to speak about simplifying today. We're going to eventually work this into, yes, it would. Thank you, Roxana. I caught. Excuse me. We're going to eventually work this into solving, okay? And that's where our excluded values are definitely going to pop up more, is when we go to solving. All right, we're going to, what factors can be divided out of the numerator and denominator? Okay, so in general, what factors can be divided out? We would say like factors could be divided out of the numerator and denominator. All right, so we are going to write equivalent rational expressions. So given a rational, there are different ways to write equivalent rational expressions. And rational is just a fancy word for one of our favorite math F words, right? Fraction. So all that rationals are, all the rules that apply to fractions apply to rationals, okay? So when common terms are divided out, the result is an equivalent simplified expression. So what they're wanting us to do is they want us to write 3x over x plus 3 as an equivalent rational expression that has the denominator x plus 3x plus 5. This is a little bit weird, but they're trying to get us to see a common denominator and create one. I don't think I put any of this particular one on the homework, but it's a good lead up into what we're going to do in the next example. So let's start with the original problem here, which is 3x over x plus 3. And then they want us to create this common denominator. So they want us to create x plus 3 times x plus 5. So here's what I would do. I am going to compare, okay? I am going to compare my original denominator to the denominator they want us to get, okay? I notice that they both have x plus 3. What's missing in the original denominator that they want me to get in the answer? Can you tell me that in the chat? So what's missing from the original that they want me to get in the new one? Yeah, x plus 5. Excellent job. Okay, so what I'm going to do is I'm going to multiply by what's missing. Okay, so I'm going to write that down. I'm going to multiply, and technically you're going to multiply top and bottom by what is missing in the denominator, or in the new denominator, okay? Someone decided not to take his nap. Okay. So technically what I am doing is I am multiplying x plus 5 over x plus 5. Because what's going on is I'm really multiplying by 1. There's a few ways that we don't change an expression. We either add 0 or we multiply by 1. Okay, so by multiplying by 1, that's what we're doing right now. So what does instinct kick in and tell you to do here in the numerator? So what do you think we're going to do here with the 3x? Awesome job. We are going to distribute. So I get 3x squared plus 15x. I'm going to leave the denominator the way it is. So this fraction, this new fraction, is equivalent to this old one because we multiplied it by 1. Basically, we multiplied it by 1, but our 1 was fancy. It looked like x plus 5 over x plus 5. Okay. I'm going to take one step back here. Okay. So if I wanted to make, it's the same thing as if I wanted to make 3/4 equivalent to something over 12, okay? So I know that 12 is 3 times 4. I would have to multiply, I know I have this one, I would have to multiply top and bottom by 3. Okay. So it's the same thing as making an equivalent fraction. We're just taking a polynomial and putting it in the into the fraction. Okay. And I know that this is probably the first time you're seeing rational expressions. Okay. I was going to try to go at like double the pace today, and I decided not to do 2 sections today. So I was trying to not totally kill you with it. Okay. All right, here comes the fun part though. Let's do something fun because we need to do something fun. It's math class, right? We're supposed to simplify the expression. So this is kind of part 2. One of them is let's get a common denominator, which we'll see more of in a minute. But what can we do to make this simpler? So now that we've done like quadratics since like, I don't know, how long ago have we been doing quadratics? Since at least like October, right? What do you think I should do with this numerator? What is instinct kicking in? This is a squared. And telling you to do with that numerator. What do you think? Ah, yes. We love the magic X, right? As soon as we see a trinomial, instinct kicks in. We're going to do good old magic X. Okay, so help me out with my magic X. So 2 numbers that multiply to 6 and add to 5. What are we getting, everybody? All right. 2 and 3. So we're going to write x plus 2 times x plus 3. I didn't need a box, right? No leading coefficient. Okay, check this out. This is such an awesome problem because when we have rationals, we not only get to factor once in a problem, we get to factor twice. Check this out. We have to check out this bottom one here and see if it factors. So 2 numbers that multiply to 2 and add to 3, what are they? Again, make sure you're participating. I'm not seeing quite everybody putting an answer in. I want to make sure you're there and helping out and paying attention. All right, much better. Good job. 2 and 1. So we've got x plus 2 times x plus 1. And then check out what's hiding in here. We've got an x plus 3 just hanging out, right? Okay, now here comes the fun part. Yes, it's the fun part of math class today. We are going to cross stuff out. So if the numerator, something's the same in the numerator and the denominator, that means it's just 1. So in the numerator, I see x plus 2, and in the denominator, I see x plus 2. I get to cross it out. Look at this. I also have an x plus 3 and an x plus 3. I'm going to cross them out. So I've now simplified it. Now, I want you to think about this question very carefully. Technically, what's left in the numerator? What is left in the numerator? Make sure you're looking at the numerator, not the denominator. Oh, we're gonna have some. Ooh, interesting. I'm really glad I asked this question. Okay, so you all need to pay attention right now because we're going to clear up the misconception. Okay. It looks like there's nothing left, okay? But remember, no matter what, there is always 100% of the time a coefficient of 1 hanging out, okay? Because there's something left in this problem, right? There's definitely an x plus 1 in the denominator, meaning that we can't, it's not just 0. We know that because if I put a 0 in the top, that would mean it would be 0 divided by something, which would be 0. So I can't have that, but there's always an invisible 1 coefficient. So my numerator is 1, my denominator is x plus 1. Okay. All right. Yes, he was hiding. You got it. He's invisible. We don't call him imaginary anymore, right? You can't call him imaginary because that means something else. But he is invisible. So we had to get him out of it. So we had to play hide and go seek. The ones, okay, Logan, excellent question. Okay. The ones do not cancel. Okay. I got to find the meme. Okay. So there's a meme out there that talks about a kitten dying. I will find it for Friday. okay, and bring it in. So that we remember this concept. You cannot cancel over addition or subtraction. If you do, a kitten dies. Okay. All right. So I didn't make it up. I just repeated it. So this and this would not cancel. Okay. If I had an x plus 1 times the 1, then I can cancel. If these, as long you have to have them added together. Okay, so it has to be exactly the same on the top and the bottom. If I had 2 over 2 times x plus 1, then my 2's could cancel and I'd be left with a 1 in the numerator. So this is basically like this. If you still have a denominator, there's a 1 in the numerator. Okay, always. There's never going to be a 0. Your 1 in the numerator is probably not going to cancel with anything in the denominator. Okay, all right, let's look at your term. Okay. So we're going to do this again. We're going to repeat the process a second time, okay? And I believe my goal is, let's see, I think I got to get through explain 2 during the main part of class, and then you're going to do explain 3 and homework during async time, okay? That's the goal. All right, so we're going to write, and it's an equivalent expression with a denominator of x minus 5 times x plus 1. Okay, so the first thing I want to do actually is if I see anything that's factorable, I am going to factor it, okay? What do you notice about that denominator? It says 5x minus 25. Is there something suspicious about that I could, or that we notice, and or we had just our gut instinct is I got to do this right now? Oh, we've got a greatest common factor. That's right. So 5 times x minus 5. Now, we're going to go ahead and cancel. So I'm going to cancel these guys. Technically, okay, help me. Let me check for understanding what's left in my numerator. Ah, yes, learning has occurred. Good job. Good job. 1's left in my numerator. So 1 over x minus 5. Okay, so that's what I've got. Now I want to write it with this denominator. So I'm going to write an equal sign. I'm going to write x minus 5 times x plus 1. Okay, so let's check it out. I'm not going to check that. I'm going to ask you. Let's see if you understood this when I taught it a few minutes ago. So what is missing from the original that's in the new one that I'm going to have to multiply by? So what am I going to need to multiply top and bottom by? Excellent job. I'm glad that the communication is working, because I always feel awkward asking that question. That's always an awkward question. I don't know what it is. It comes out of my mouth the wrong way, it seems. All right. So technically, I'm multiplying top and bottom by that. The denominator is taken care of. Technically, we distribute the 1, so we get x plus 1 in the numerator. Okay. And then, this is a weird problem, isn't it? Because it's going to make everything cancel, isn't it? I would probably leave it like that because it's weird because we want that to cancel, right? But they asked us to write it that way. So I would leave it. Again, it's more practice in getting a least common denominator than anything else. Okay. So it will, that part will make more sense in a few minutes, the least common denominator part. Okay. Let's take a look at simplifying. This is an interesting one. It looks like, I'm going to rewrite it because it is kind of fuzzy. So it's x plus x cubed times 1 minus x squared over x squared minus x to the 6th. Oh my goodness. We've got quite some factoring to do there. Okay. Lots and lots of factoring, but we know it's a simplified one, so it's going to get fun in a minute because I get to cross some stuff out. Okay. So let's take this little factor by little factor. Let's start with this guy here. So what I just underlined in green. What kind of factoring am I going to do? What do you guys think we need to do on that one? Tell me in the chat, what do you think we should do? I got 2 terms, but what's the first thing I always look for? That's what I want to know. Oh, greatest common factor. Excellent. What is the greatest common factor of the green? What is it? Ah, nice job. It's an X. Good, good, good. Okay, so I'm pulling out an X. I'm going to pull it out in green though. Pulling out an X, I'm left with, remember, I'm dividing this in here. When we divide, we are subtracting exponents. So I get 1 plus X squared. All right, let's work with this one here. So I have two terms. I don't see a greatest common factor. Two terms. Got to ask myself, are they squares or are they cubes? So what kind of factoring am I doing now? What do you guys think? What's it called? We talked about it a few minutes ago. All right, nice job. It is difference of squares. And I know it's written weird and backwards, but we're going to go with it. All right, so we take the square root of 1, which is 1. We take the square root of x squared, which is x. Make 1 a plus and 1 a minus. All right, we've done that a whole bunch of times, so we should be good at it by now. All right, let's take a look at the denominator now. The denominator is going to have us do factoring a few times. So the very first thing we're going to look for in that denominator is the greatest common factor. Is there one? And if so, what is it? What is my greatest common factor? Oh, David got fancy. Oh, Josephine did too, and Everlyn, or we're copying and pasting. I don't know what's what. All right, so I don't know if you guys saw that link I put to Simple Salads. Simple Salads got some good stuff in it, but it's a little takes you time. It takes time to copy and paste. All right, so yes, it's elite, definitely, Amy. All right, so it is x squared. So x squared. And we're going to factor that out. We get 1 factored out, and we're going to bring out, and we divide. Remember, you're subtracting your exponents. So you would subtract the 6 and the 2, and that would give me 4. Okay, so I am not done factoring the denominator yet. Okay, because again, look at it. I can't cross anything out yet, and crossing stuff out fun. So I need to do more. Okay, so I'm looking at this, and I'm wondering to myself, can I factor that more? Okay, I know it's not greatest common factor. I've got 2 terms. I have to ask myself, are those 2 terms squares or cubes? So what kind of factoring do you think we need to do now? Tell me in the chat. What do I need to do now? I'm going to write everything out while you guys are putting it in the chat. Actually, I'm going to do something different with this. All right, nice job. We got to do difference of squares. Okay, before I do the difference of squares piece, I am going to purposely take apart that x squared and write it as x times x. Okay, now I'm going to do my good old difference of squares. Okay, so we're going to take the square root of 1, which is 1. I'm going to take the square root of this. So what does that mean I am dividing this exponent by when I take a square root? What number do I divide the 4 by to take the square root of it? Tell me in the chat. What do you think? Ah, nice job. We're dividing by 2. Good, 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 good. So we've got x squared and x squared make 1 a plus and 1 a minus. All right. What cancels? Tell me in the chat. What do you see that cancels? What do you think? All right, I am seeing x plus 1 squared. Okay, so I'm going to get rid of that. I'm going to go red for my canceling. So x plus 1 squared. All right. Oh, we can take out x too. Okay. All right. You know, I think we can do better than that. Does anybody, I'm curious, does anybody else see anything else we can do with this? Is there one other thing I could do, and then maybe that would cause some more canceling? I'm going to give you a hint. Look at the denominator. Is there anything else I can still do with the denominator? Oh, Amy is suggesting, difference of squares, Alondra. Okay, we have some more work to do, don't we? We need to do some difference of squares factoring here. I wrote way too big, didn't I? Hopefully you aren't writing as big as I am. All right, so I still have an x down here. I'm going to do difference of squares on this. I'll do that in pink. All right, so square root of 1 is 1. Square root of x squared is x. Make 1 a plus and 1 a minus. Oh my goodness, look at how much fun this is. I'm going to get out the sparkly pen, okay? So, because it's so much fun. Because look at this. That's going to go, that's going to go, that's going to go, that's going to go. What's left in the numerator? Just the numerator. What's left? Oh, I didn't trick anybody. Good job, 1. And my denominator is always just an x. So we got that from this ugly mess down to 1 over x. Wasn't that satisfying to get it that ugly down to something that looks so nice and clean? Okay. All right. So tomorrow or Friday's lesson is kind of more of the same of the simplifying. Ariana says, yeah, it is. See, math is awesome. It's fun. So Friday we'll see how we turn it. We'll do rationals with multiplication and division, and it's basically just simplifying. We're going to add an extra step or two. Okay, and it's just all this is simplifying. So if you're not up on your factoring, you really need to make sure you have that skill. That's probably like in all of algebra 2, factoring is like the #1 skill. It's great if you can graph a line, but factoring is where it's at. Okay, you've got to be able to factor. Okay, we use it all the time next year in calculus, and I just say factor it. I don't teach you how to do it anymore. Okay, so you have to have that skill, and this unit reinforces all that factoring. Okay, all right, let's take a look at explain to. Okay, it's going to build on everything we've done so far. Okay, so hopefully it's. Okay, so we're going to talk about how to create a least common denominator, which is really the same as saying a least common multiple. You have all done this before because I know you've done fractions. Okay, I know you've been doing fractions since probably about the 3rd or 4th grade at the latest, right? You've seen fractions, you've dealt with fractions before. Okay, so I am going to be very specific in what I am doing, and I am going to use a red pen for circles. Circles in red, and I'm going to do underlines in blue. Okay, and I'm going to be very specific about that as we're learning this technique. You are welcome to use different colors. You are welcome to do this technique on the test. Okay, if it helps you see it. I think it helps it pop. Okay, so let's take this. I'm going to go do a side problem really quick before we do the example 2, actually. Okay, so let's try the problem. Let's try to find a least common denominator between I should not have used blue. This is Ballard. All right, between 1/12 and 1/18. Okay. I absolutely hate factor trees, but I'm going to use them right now. Okay. Factor trees are my least favorite thing. I think they take up too much space on the page. All right, so I'm going to ask myself, what times what is 12? So tell me in the chat, what times what's 12? What root are we going to go here? All right, Amy's was first, 3 times 4. And then I know 4 breaks into 2 and 2, right? Okay, everybody came up with the same one first. Good job. All right, what do I break 18 into? What times what? What do you guys think? All right, 6 and 3, that's the one I'm going to go with. 6 and 3. And I'm looking for the prime factorization, so numbers that I can't divide in anymore, right? So I'm going to go to 2 and 3 there. All right, so comparing the 2 sets of numbers, I am going to write those in my denominator over here, actually. So I'm going to write 3 times 2 times 2 for that denominator. And for this denominator here, I'm going to write 2 times 3 times 3. Okay, now I am looking for friends. So I'm going to use red, and I'm going to circle every time I have a match between the 2 denominators. So I have 1, 3 here, means I get to circle 1, 3 here. Okay, I'm going to go, I'm still circling in red. I have 1, 2 here, means I get to circle 1, 2 here. There's nothing else that is a pairing, right? That has a partner in the other denominator. So everything I circled in red, I get to write down 1 time. So red, write once and once only. So I get a 3 and I get a 2. Now I'm going to underline in blue. And everything I underline in blue gets written down. So 2 and 3. This is going to be your LCD. So my LCD of 12 and 18 would be what? 9 times 4, 36. Okay, so that was the elementary school version. Let's take this back to Algebra 2. Okay, so let's, first thing I'm going to have to do is factor the denominator. So I am seeing in this first one a greatest common factor of 3. So I'm going to pull the 3 out. I'm going to keep the -2 on the top, pull the 3 out. Okay, tell me what's left behind. When I take out the 3, what's left behind? Okay, nice, nice, nice. X minus 5. Okay, and then in this other one, I'm going to pull the 4 out. What's left behind? All right, X plus 7. Nice. Now, I'm going to use my same technique, and this was a terrible one to do first, but it is what it is. There is nothing I can circle in red, right? There's nothing that matches between those two denominators. So in this case, I would underline everything in blue. My LCD would be every single thing, which is like the worst case scenario. I mean, I got to multiply all that stuff out to get my LCD, right? So I would multiply 3 times 4 times X minus 5 times X plus 7. Likely I would put my constants or my coefficients in front of my binomials. Okay. All right. The next one's a little bit more exciting. So let's try the next one. Okay. All right. So what type of factoring am I going to have to do on those denominators? I got some nice trinomials hanging out there. So what do you guys think? Nobody knows. We got trinomials. We got a factor. What are we going to do, guys? There we go. We're going to do some magic excerpts here. Awesome. Okay. So I need two numbers that multiply to 24 and add to -11. Can you help me out with those? What are we thinking? I know I lost the rhythm. I was doing really good, and then we lost the rhythm of the lesson, huh? All right, -8, -3. We agreeing? Let's see, I got Amy. Anybody else? Do we agree with Amy? Okay, here we go. Either that or I've got a delay going on now. Okay, perfect. So I'm going to write the 14, what on earth am I looking at? Look at the room screen. -14 over X minus 8 times X minus 3. Okay, did you already do the next one? Are you ready for it? All right, I need two numbers that multiply to 9 and add to -6. What are they? Apparently not. All right, Amy says -3. Valerie says -3. Okay, here we go. -3, -3. We got to have some agreement here and got to make sure we're all on the right page. So X minus 3 times X minus 3. Perfect, perfect, perfect. Okay, so in red, I'm going to circle what matches. So I notice that I have 1x minus 3 here and 1x minus 3 here. How many times do I get to write down what I circled in red? Can you tell me that in the chat? How many times do I write down what I circled in red? I'm waiting. I want to make sure I get like 2 full screens of that because this is an important step. All right, excellent work. So X minus 3. Perfect. Okay, now I'm going to underline in blue. And literally, you guys, if we were in my classroom, I would make you use these colors. We would have the colored pencils out and be like kindergarten today. We'd be underlining and circling in the right colors. Okay, totally color coding our lesson. Okay. All right, so I am going to write everything that I just underlined in blue. So X minus 8 times X minus 3. Okay. If you want to be super cool, and I know you all do, right? You all want to be super cool. The fancy way to write that would be X minus 3 squared times X minus 8. I'm super cool, so I would write it that way. Okay. All right. We are going to skip the reflect statement, and we're going to try to do, I don't think we need to do both of them. Let's do 6. Your turn 6. Okay. So we're going to skip this. You get to cross it out. You get to cross that one out. Okay, let's do 6. Okay. What type of factoring do I have in that denominator? I'm going to blow it up a little bit. I'm not sure it's going to make the blur any better, but we'll blow it up in size a little bit. What am I going to do in that first denominator for factoring? What's the very first thing we need to look for when we factor? The greatest common factor. Nice. Okay, so I think it's 15. You always agreed it's 15. If you don't know what 15 times 60 is, you should, because it comes up a lot. So it's x plus 4. Okay. All right, and then my other one is 5. What kind of factoring am I going to do in this other denominator? Don't disappoint me this time. We have a trinomial. There we go. Thank you, Roxana. Oh my gosh. Good job, everybody. Magic X, magic X, magic X. Nice job. Okay. So I need 2 numbers that multiply to 20 and add to 9. What are they? You guys have, I think those were typed before I finished answering the question. Are you all working ahead again? All right, so 4 and 5. Doesn't matter the order. So x plus 4 times x plus 5. Okay, well, here comes my checking for understanding. What am I going to circle in red? So what's the same in both denominators? What am I circling in red? Nice job. Okay, so we're going to circle the x plus 4s. So my LCD is going to be x plus 4. And then I'm going to underline in blue the 15 and the x plus 5. I'm going to squeeze my 15 here in front. X plus 5. You don't need to multiply it out. Again, this is an intermediate step. Okay. What you're going to do next is you're going to, after we do the joke of the day, you're going to get up and take a 10-minute break. Okay. And then you need to sit down. I mean, literally, you need to stand up before we do any more math. Okay. You need to stand up and move around. Okay. And then you're going to watch Explain 3 on video. Okay, so I videoed it for you this morning. There's 4 examples there. I did change 2 of them because the book was not doing justice to what you needed. So I changed a couple of them, and it should make it better, actually, and to make it more like what the homework is like. Okay, because they put some in the homework and then they didn't cover them in the notes. It was really weird. Okay. All right, are there any questions, comments, or concerns that I need to take care of as I'm getting